That will be very helpful to know. Thank you so much. The question will be up for 30 more seconds and then I'll close this. So now I end the poll. And I'm going to share the results, and I request both the speakers to have a look. Majority feels that quality of connection and cost of the device to access the internet is one of the problems. Uh, I am stopping this poll and we come to the next question. And here is the next question for you. This is about the semiconductor industry, the topic that we are going to discuss today. What can India do to reduce its reliance on importing semiconductors? And there are four options: offer better subsidies and incentives to attract new players, develop skilled workforce in India for the manufacturing of semiconductors, and encourage joint ventures between global manufacturers and local players. So those people who have joined just now, I request you to look at this poll question on your screen and give your opinion. This is very, very important for today's topic, and this will also give some hint to our speakers to comment on the topics today in the webinar. They have several questions. And thank you so much for quick participation. I can see people are quickly giving their views. So I think this question will be there for 15 more seconds, and then I'll move to the next one. Thank you so much for giving a very quick opinion on this poll. I end the result and share with everybody. Share the result, sorry, with everybody. And you can see, I request Momita and Pranay to have a look at the responses. And they want global manufacturers to collaborate with local one. Now I end this, and here is the last one, and then we'll go to the next part. And the way you responded to the previous questions, I request you to respond to this one as well. That was really quick and very swift response. So which of the following could be the main reason limiting India to manufacturing semiconductors in-house? So heavy investment in infrastructure, tough competition from global giants, lack of availability of high-tech facility, and lack of skilled workforce. These four are, all of them are attractive options, and they all are equally important. But we would love you to opt one so that we know what the audience thinks. So thank you so much for this. I can see the responses are coming very swiftly. This will be up for 15 more seconds. Now I'll end this poll and share the result. So here we go. And we know that tough competition from global giants, and there are two giants. One is China and one is the US, and we know what is going on. And that's why we thought to have a webinar on this topic. So again, I welcome everybody. Thank you so much for joining us. I'm Sudhir Pandey, and again, I welcome you to Ahmedabad University. Today, on this topic, we have Pranay Kotasthane with us. He's a Deputy Director of Takshila Institutions. And Pranay's current research include high-tech geopolitics and the politics of radically networked societies. He teaches public policy, international relations, and public finance at Takshila's graduate and postgraduate programs. He co-writes Anticipating the Unintended, a newsletter on public policy ideas and frameworks, and co-host Pulia Bazi. Most of you may be familiar with this, a popular Hindi-Urdu podcast on politics and policy and technology. He has co-edited India's Marathon, Reshaping the Post-Pandemic World Order. A very interesting concept that he promotes and he wants to popularize. He calls it societism, the idea that society, like market and state, has a distinct role in any human community. And Pranay has contributed many opinion pieces on this and essays in several Hindi and English outlets. And we are very happy to have you, Pranay, at Ahmedabad University. Welcome again, and thanks for joining us.
Thank you so much.
Thank you, Pranay. With Pranay, the in-house professor who will be in conversation is Professor Momita Rai. She earned her PhD from George Mason University recently. She obtained MA in economics from George Mason. Before that, she did her MSc in economics from Madras School of Economics. And her research areas are applied microeconomics, experimental economics, behavioral economics, and political economy. Before that, she has also worked at IIM Bangalore. So it is pleasure to have you, Momita. And I request you to take this conversation forward. Before that, as you know, the rule is that everybody will be muted, all the other people except are both the speakers. And we want you to put your questions in the everybody's chat box so that while the conversation will be on for the next 60 minutes, we can take your questions, curate it, and at the end during Q&As, we'll put your questions and that will be answered. So thank you so much, and you may please take it forward.
Thank you, Sudhir. Thank you for the introductions and thank you for conducting the polls. I think those were some really interesting poll responses. Welcome, Pranay. I'm really looking forward to this conversation. I think, if I may say, semiconductors pretty much rule the world today. Nobody can say that, they can't deny their existence in their life. So I'm sure this is going to be a very exciting and interesting conversation. So my idea for this conversation was to talk about the semiconductor industry with a special focus on India. But before that, to start it off, if you could just give us a little background about the semiconductor industry, especially for like laypersons like me, that would be a great help. So if you could start.
All right. Yeah. Thanks so much. So glad to be here, especially at Ahmedabad University. Have heard so much about the university and glad to be talking to you all. I also know there's a test match going on. So the fact that you are here only means that either you hate cricket or you are confident that India is going to lose. So either ways, happy to be here. To begin with, I thought, like Momita mentioned, I will just briefly take you through some details about the semiconductor industry before we jump into the geopolitics of it. I think there are unique things in its supply chain, in the way it has evolved. So I thought it would be a good intro. So let me just share my screen. I will quickly take you through. Pardon for taking some time on this. Yeah, I guess this should be visible.
Yeah.
Yeah. All right. So so as Momita mentioned, how semiconductors are really important. So I would say that it's the world's most important industry that you never thought about in our common conversations. And I feel that it's the rapid advances in semiconductors are really a feat of human ingenuity and also of human organization at all. And I'll tell you why. Any advancements that we talk about today, from from the defense space to iPhones to anything, semiconductors underlie a lot of those things, and especially how the industry has evolved has a lot to do with it. So really briefly, I'll begin with what they are. Right, so semiconductors generally refers to the material used, which is commonly silicon or germanium. And why it is called so is because its conductivity is in between insulators and conductors, right? So that's why semiconductors. And really the superpower that exists is that you can actually control the flow of electrons in such a kind of material if you design it in a proper way by using another controlling current. Now, when you can do that, you really have a superpower. You can convert that particular design into an amplifier, into a switch, into something that can store a value. So it really unleashes power that no other material can, right? So that's really the basis of why semiconductors are important. This idea that you can control current based on another controlling current in a particular material. right? So that's where the story of semiconductors starts. And broadly, I will just tell you about this. If you see what's on your screen, most electronic components sort of will have semiconductors and non-semiconductors. So for example, sometimes you would have transformers, you would have batteries. They are not semiconductors, but apart from that, everything else is semiconductors. And within semiconductors also, you have different kinds of semiconductors. So you have LEDs. LED is also a form of semiconductor, which is an optoelectronic semiconductor. There are discrete transistors, there are sensors in your cameras, and then there are these four on your left. And these are really what we call as ICs, integrated chips. Now, these are integrated circuits, and these are really important because currently, if you look at the entire value chain, they account for 80% of the entire semiconductor sales, right? So whatever I'm going to speak from now on and we are going to discuss about is actually about ICs. And colloquially, people call them as semiconductors because they occupy such an important role. The really interesting thing was, first you had this idea that people thought you can convert semiconductors into transistors, and those transistors can do basic things like I told about amplification. You can convert it into a switch, you can convert it into something which are logic gates and function, not function, whatever, right? That was the beginning of it. Then people in 1950s was this great thing which came out, which was the IC, right? And what we are talking about, that the idea there was that you could combine several components and functionalities on a single chip, instead of having them on a motherboard and then you are going to connect it with wires. So that was really that unleashed the powers, because you could pack lots of functionalities in an IC. Actually, I have an IC, so yeah, you would have seen this kind of IC in many of your devices, right? So this was a Nobel Prize winning invention, of course. And then there was something which came to be known as the Moore's law, right? And Moore's law is actually not a law. It is just an observation based on how the technology was advancing. So what the Moore's law stated was that approximately every 2 years, the number of transistors within a dense integrated circuit would double. Okay, so that was the observation. It was based on a historical trend. It was not a law. But the surprising thing about semiconductor industry is that that sort of observation has held true for nearly 40-50 years. So that's really something which doesn't happen in any other industry, right? So I mean, you think of the LPG cylinder in your house. It's not as if its performance increases by twice every 2 years. Or you can think of your car mileage doesn't improve by twice over every 2 years, but ICs, the performance could improve by every 2 years. And the way this performance improved was that you started packing more and more transistors and semiconductor material and functionality within an IC. So just think of it, when this Moore's law was sort of mentioned, at that point of time, an IC had around 64 transistors, okay? And today, an Apple A14 chip has 134 million transistors per millimeter square. So, I mean, just look at where we've gotten from where we started, right? And that's really the amazing part of this particular industry. So in fact, at that point of time itself, in 1965, when there were 64 transistors in a chip, Gordon Moore, who later became the CEO of Intel, had mentioned about how their ICs will lead to these wonders called home computers and automatic controls for automobiles and things like that. And that was 1965, right? And sort of all the things came true at some point of time. Also think of it this way, that an inkjet printer at our homes now has more computing power than probably what NASA had when they launched their missions to the moon. That's where how fast and how forward we've come in the semiconductor industry, right? So because of this particular advancement and the way it has happened, we expect something very different from this particular industry compared to what I talked about, say cars or your other fuels, right? So that's something unique. Now, why did this happen, right? As I told you, it is just an observation, right? It was not a law as such. So what has really happened is one, inventions, innovations in the products and the materials itself. But the other big reason why this has happened is the unique supply chain. And I always think that if someone has to teach economic concepts like division of labor, comparative advantage, globalization, I think semiconductor industry offers a great case study for explaining all these. And the way it happened is this way. So I'll just briefly talk about the supply chain, because that's really the core of where the geopolitics is playing out. So if you look really broadly about manufacturing a particular IC, it passes through these broad stages. All right. So first stage would be R&D. So this will be a really capital and skill intensive stage, where you would actually try to evaluate test chips. You will try to see whether you are able to achieve a particular functionality with lesser amount of power consumption, or are you able to increase the speed at a particular that, let's say, your games that you play on your phone, are you able to play them with the performance that you require? Or let's say you are able to get a camera processor which can which can sort of work at night time. So various kinds of things, performances that you want to optimize for. You are going to first see whether your material is capable of doing that, whether you need to go to lesser and lesser sizes to pack in more performance in the same space that you have on a phone, right? So that is essentially what the R&D stage does. And the industry-wide investment rates, it is one of the most heavily R&D intensive industries in the world. Almost 15 to 20% of the sales goes into R&D, right? So that is one. The second part is design, right? So this is a very human capital intensive stage where companies will conceive of new products, they will conceptualize new products, they'll make specifications which meet customer needs. So Apple might come up to a semiconductor company and say, I want this phone to have so and so features, to be able to play XY games, to be able to have so many megapixels of camera. So you would get together, a company will design the particular processor which will be able to meet this specification. In Apple's case, Apple's own semiconductor unit would do that, but generally it can be outsourced to others as well, like it happens in automotive industry sometimes. So design, basically, you can imagine if you have 134 million transistors on per millimeter square, obviously you can't do this by hand. So there are specialized software for this, which are called EDAs, electronic design automation. So there are companies for it. And then you have intellectual property companies, which actually give you course, processor, blueprint of processors, which you can then convert into a design. All right, so that's the design. The next stage is manufacturing. Now, this is again a very capital intensive industry, and you need huge upfront costs for this. So this is where the actually your blueprint of your design gets finally converted into a physical chip. And obviously this requires you to have semiconductor materials. You need to have the process which is used for this requires extreme amount of cleanliness. You can imagine, a single strand of hair will occupy many more transistors than the size of the transistor. So even if you have one hair falling or one dust particle falling, on a chip, its functionality is totally lost, right? So you need to have ultra clean environments. All those costs really high. Like today, if you want to manufacture chips which go into your Apple phones and the processors, you need upfront costs are around $12 billion, right? So what, 80 to 85,000 crore rupees. So that's the kind of investment required in manufacturing. And finally, after manufacturing, you have assembly, test, and packaging, where you convert a silicon wafer into what an IC looks like, right? So that's the entire stage, the supply chain. And the assembly, test, and packaging is mostly labor intensive. You would require lots of people who are able to do this assembly and testing, right? So this is broadly how the supply chain looks like. Just to recap, design would be human capital intensive, a lot of R&D required there. Manufacturing would be a lot of capital intensive functions, and assembly and testing would be labor intensive, right? So that is broadly how we understand it. Now, the most beautiful thing that happened in this industry, and that's why I said comparative advantage, earlier, all these steps used to be done by a single company. Okay, so one company like Intel would do all this for their processors, right? And many other companies used to do the same thing. But you can realize that as we started going towards the Moore's law direction, you had to improve that processes every 2 years, right, in order to get more and more functionality, more and more performance. And the only way you could do that was to improve your manufacturing facilities, right? And that again required a new manufacturing facilities, new production costs, etc., right? So upfront investment, like I told you, is billions of dollars, and that you can extract advantage of it only for 6-7 years. Then you want to go to the next node. The next node will pack in more transistors, so you need to do again more upfront investment, right? So you can imagine this was really cumbersome for any company to get involved. So that's when something wonderful happened, that the comparative advantage, the division of labor sort of moved towards the fact that all manufacturing started getting done through contract, right? So instead of a company having its own manufacturing unit, contract manufacturers emerged in the 1980s in East Asia mostly, and currently Taiwan, which has the TSMC, is probably the most important technology company in the world now. And TSMC sort of does more than 50% of contract manufacturing. So whether it is Apple, whether it is AMD, whether it is many other companies and many other phones that you use, their processors would have been designed, contract manufactured at TSMC. Now, why this was important is because it led to a really nice thing, that you could actually, if you have a company, you could only focus on doing the design part, right? And that's what came to be known as the fabless companies, because you don't have a fabrication unit, which is required. So all the companies like Apple, Google, AMD, all these companies could just focus on getting their design right, and they didn't need to invest in manufacturing. They didn't need to put money there. They could just create the blueprints, and then they could give it to contract manufacturing to a company like TSMC or others in East Asia. So you can imagine the upfront cost reduced, a bunch of companies flourished, the fabless market sort of exploded. There are fabless companies across the world now, but manufacturing is still concentrated in one region and in a really few countries. So that's sort of what became a bottleneck. And I'm sure we are going to be talking about that a lot more, but this is how broadly it is. And just to sort of again reiterate, there was, to begin with, there was this integrated device manufacturer, basically one company doing all these functions. Over time, you had this division where only some companies did design, a few companies did contract manufacturing, and others did outsourced assembly and test, again on contract, again, which is concentrated in East Asia, China, Taiwan, South Korea. So this is how sort of this comparative advantage led diversification happened, and now this industry is one of the most globalized industries in the world, in the sense that every IC would travel 4 times across the world approximately, because some part will get manufactured elsewhere when you would have other parts being manufactured in another country, and that's how it operates. So until now, this industry works so smoothly that we didn't need to know about it, and we didn't need to bother about how it all this fell into place. Things just fell into place until what happened during COVID-19 and what happened with US-China confrontation. So I'll stop here, Momita. If we want to discuss more about this, we can. Otherwise,
yes, absolutely. Firstly, thank you for that great introduction. You explained the supply chain so simplistically that it was very easy to follow. So thank you for that. And I definitely would like you to continue on that. Like, now that we have a basic understanding of the semiconductor industry, if you could talk more about how critical the industry has become in the geopolitics of nations, especially as you mentioned, with the US-China, intensifying US-China technological rivalries, if you could comment on that. And also, where does India stand in all this?
Right, yeah. So, yeah, to begin with, I really like this quote by Willie Shee at the HBS, Harvard Business School. So he explained this sort of with an analogy. He says that the semiconductor industry structure can be thought of as a transcontinental relay race with hidden hurdles, right? So think of it, imagine this sort of industry, and it is precisely that, right? So it is a transcontinental relay race. You are manufacturing only a part of it and handing over to others. And there are hidden hurdles. Hurdles are there because there are only a few companies which are concentrated in a few countries which do one part of this entire chain. So if you are able to control those companies or exert influence on them, you can place hurdles in the path of another country, right? So that's what is essentially the geopolitical importance of it. Now I will come to some specifics. As I told you, the contract manufacturing is at the nub of all this, because all of this is happening in Taiwan, and you all know already how US-China relations and especially in the Taiwan Strait, geopolitical tensions have been rising. So there has been this threat that if China were to take over Taiwan, not because of semiconductors, but for the political reasons, semiconductors would just be a small reason for that. But if they were to take over, then even the US loses out on a lot of manufactured chips, right? So even some of their fighter planes, some of their top-notch companies are all manufacturing their products through TSMC. So whether it is Apple, whether it is Google, whether it is even Boeing. So some of these companies which are really critical for the US, they are all manufacturing in Taiwan, and that's really the problem in the present times. The second thing was there are increased cyber attacks from China on TSMC, on Taiwanese companies. So that's again a threat which many countries are realizing, right? So that's sort of one angle to this. The second part is, broadly, if you think technology would be a big source of power in the information age. Anything related to technology, one thing that will underlie that is advancements in semiconductors. So that's why I call semiconductors as being metacritical. And from that angle, if you are able to stop a country's progress in this domain, or you are able to accelerate your own progress in this domain, then you have an upper leg in this particular era, right? Where so much of our confrontation is happening in the technology sector and not necessarily only through wars, right? So that's that's one important point. The second sort of thing that has happened is over the last 2 years, there have been allegations about espionage through hardware. So there has been two stories that Bloomberg had brought out, which sort of talked about how on motherboards there were some chips which were put in by agents related to China, and they were trying to give that information back to China, right? So now this is heavily contested. Many people think that that was not the case, but yet DARPA, the US Department of Defense, is investing a lot of money in improving the security of hardware. So it means that there is some concern, at least, if not outright espionage. The third part is that you can actually hurt another country's economy if you are able to deny access. So just look at what happened in the US-China case, right? So China, or like US, manufactures a lot of its it is, by the way, it consumes a lot of, it makes the final product. So final products would be made, Apple iPhones could be made by a Chinese supplier, but they don't have a really good semiconductor IC setup. So they would still do the final assembly, test, integration, etc. But they wouldn't have the capability to make an Apple iPhone chip inside, right? So they a lot of Chinese companies are also reliant on Taiwan. So what the US did was it imposed secondary sanctions on TSMC. What it said is that since TSMC uses semiconductor manufacturing equipment made in the US, so it banned TSMC from supplying ICs to companies like Huawei and others, right? So that sort of was a big blow for Huawei, and their plans have gone astray because of this, right? So this is just an example of how one country can hurt another country's economy. It has hurt their 5G plans, it has hurt their mobile phone business, etc. Right? So this is really the important part on the geopolitical side. Now, next, you asked about India's role, right? So India has its own comparative advantage, I would say. So a lot of semiconductor IC design process, which I talked about, 8 out of the 10 top semiconductor companies by revenue have their design centers based in India. So there would be, and as I told you, it's a human capital intensive state. So you really require a huge amount of engineers who would know the basics of VLSI design, and that's where our strength lies. So the semiconductors sector, by the way, in India started way back in 1985 when Texas Instruments invested in an R&D center in India. So it was one of the starting of Bangalore as the Silicon Valley of India, right? So it really started with the silicon company, not with a software company. So that was where it began. And India, over the last, you can imagine if a company has started in 1985, and over the years, there have been many people who have worked in that industry, worked through the design cycle. So there is a lot of expertise on the design stage. There is also a world-class design services company. So just like you have IT services, semiconductor design also has a services firm. So basically you do one part of the design for another company. So India has many such companies as well. What is not there in India is the manufacturing side and the research side. So specifically, because manufacturing is a capital intensive sector, you only have a few government run, or you have academia associated units, but they don't do manufacturing at the cutting edge. Like I told you about, in making an Apple iPhone chip or making an AI chip would be really difficult. But there is enough capability to do, let's say, do manufacturing of a chip for, say, space related applications. So there is something called the SCL in Chandigarh, which does a lot of space related chip development, right? So that's broadly where we are. And I hope I'm able to explain what the geopolitical tensions are and how they have risen because of semiconductors.
Yeah, absolutely. I'm glad you brought about that part about how these things can affect the economies of other nations, because there's something that I wanted to talk about is something which is making the headlines for quite some time is the global shortage of chips. In fact, I think just 2-3 days back, Maruti Suzuki announced that they're expecting, I think, almost 40% slump in their production, which is a very big number. And this is very concerning to economists. So I was reading that economist Rory Green, he compared the semiconductors and he called it the new oil, comparing the crisis now to the oil crisis of the 1970s. So from an economic point of view, you understand that this change in supply will have a massive impact on demand. So if you could comment on that, the shortage, the global chip shortage, how did this come up to be, and basically the geopolitics behind it.
Yeah, sure. Yeah. So that's indeed. So the core of all this is because of how this industry has evolved, right? So you have an extremely globalized industry, which each company, few companies in a few countries being able to do parts of it, which means that in normal circumstances, it works fantastically well, right? As I told you right in the beginning, a lot of the great things that have happened are precisely because of this structure, right? You can just do some part of it, be very good at it, and others can do some other parts of it. Now that all worked fine until we realize that the problem here is that you don't have a resilient supply chain. And if there are geographic bottlenecks, if there are geopolitical bottlenecks, then everything is thrown out of gear. Now, what happened why is there an automotive shortage is related to this, right? Again, think of it this way, like the Japan earthquake and tsunami in 2011 led to a rearrangement of global auto manufacturing chains, right? So otherwise you had so much of things, sourcing and manufacturing was done in Fukushima, and after that it moved out to a lot of other places, right? Similarly, that similar thing has happened or being because of COVID-19, right? So what has for semiconductors? Now, what happened specifically for automobiles was that once the pandemic hit, people expected that all the auto manufacturers that people are not going to buy automotives anyways, so they sort of stopped production lines and the contracts that they had given to companies like TSMC for manufacturing their chips, right? On the other hand, the demand for data centers, the demand for chips which are required for laptops, of mobile phones, all that shot through the roof, right? Because all of us are on the phone and on our computers through the day. So these two things resulted in a situation that when the demand for automotive started picking up earlier in this year again, the entire contract manufacturing setup was not able to have space for these automotives at all, because you already had an excessive demand for the other type of chips, which are already mentioned, right? And as I told you, it's just a few companies which are doing this on contract, and they would prefer to manufacture those which have higher margins, and the margins are higher for the cutting edge chips, right? So they would prefer to manufacture a chip for Apple or let's say for Huawei or AMD, rather than do that for automotives, which are generally old trailing edge nodes, which don't give them as much margin. So that's what the essential problem is. So there is no excess capacity in this industry. To build excess capacity, like we discussed, it requires huge upfront investment. To get it up, it will require 1 or 2 years. So that's the situation that we are in. Automotive, there is demand for automobiles, but you can't manufacture the chips because there is no supply of wafers left for this particular process, right? You're just being occupied by other demands on this industry. So that's what has happened now. So broadly, if you think of it, the way I thought of it is, from an economics lens, from a supply chain angle, there are two kinds of risk. risks here, right? One was the concentration risk. So as I said, geographic risk is definitely there, that you are concentrated in Taiwan, in East Asia. So forget about the geopolitics of it. But recently we saw how there is drought in Taiwan, and semiconductor manufacturing requires huge amount of really pure supply of water as well, right? So if there is something which is a geographic problem there, the entire world's all industries are going to be hit in one way or the other. So that's sort of a concentration risk that we face. Similarly, there is a business continuity risk, which means, for example, if you have to manufacture a processor which goes into Apple phones, you require a very specific manufacturing equipment for that. And that is only manufactured by one company in the world, which is ASML in Netherlands. So now if something happens to ASML and they are not able to supply that particular machine, they just make a few machines every year in tens, not even in hundreds. And they're really, you can imagine, really costly machines, and very less demand for it. Only a few companies would want those. So if something happens to ASML, the entire product line, those shock will be felt through the supply chain right up to the mobile phone that you get, right? So that's how there is a business continuity risk. And the third risk that I already discussed is the geopolitical risk, which we are seeing now. Every country is sort of seeing semiconductors in strategic terms, right? So this word strategic is overused in geopolitics, but it's sort of being seen that we need to have our own semiconductor industry because of see how unresilient or non-resilient it is, right? So that's why you are seeing a lot of contestation to get an equivalent of a TSMC or a manufacturing setup in your own country, right? So these are sort of some of these three risks. These risks existed before COVID-19, but the pandemic has sort of exacerbated it, and it has highlighted to policymakers that there is this resilience angle which we didn't care about earlier because things were hunky-dory, but now we need to worry about it in the changed circumstances.
So hearing whatever you've been saying so far, so it feels like for India especially, to get about the geopolitical risk, it seems like it's better for India to be self-reliant. But about the other risks that you're saying, the concentration risks and others, so it seems that it's better if they work with other countries to build the semiconductor industry. So what is the best way for India to go forward?
Yeah, absolutely. Yeah, that is an important question, right? And there was a poll also related to it. But I think the audience got it perfectly right, I would say, because self-sufficiency would be perfectly desirable and nearly impossible, is how I think of it. Again, I have a good quote by David Edgerton, who's a British historian of technology, and he sort of says that only in techno-nationalist fantasies do we have national invention driving national economic growth. Most often in the real world, it is global innovation driving national growth and national innovation driving global growth. And that's particularly true of the semiconductor industry, given how globalized it is. So what we've seen over the last few years is, because for getting an additional performance for every in every chip, right, the R&D costs and investments that you require are increasing non-linearly. So because now literally you have transistors sitting a few atoms apart. And so when you do that, you hit a lot of limitations of leakage currents, etc. A lot of technical limitations, but essentially you need to put a lot of money in order to get the same performance improvement that you could earlier. So what has happened is, erstwhile national industries are transformed into global supply chains, like we discussed, and each country just specializes in a specific part of this supply chain. Now, even if we see a country like US, even though it has huge, massive fiscal resources it is spending in order to again have manufacturing facilities relocated to the US. It is giving lots of subsidies of various sorts, and yet it is unlikely that US will be able to manufacture all the parts of the supply chain to indigenize all of them together, right? Purely for cost reasons, like we discussed. If you want to actually integrate all these ICs on a printed circuit board, that is an industry which is again based on really low cost margins. So you would want to have it in a place where you have cost advantages, and it's not possible in the US. Many people have tried, but it's just more advantageous to manufacture it in Taiwan, in China, or elsewhere. So despite US putting in a lot of money, attracting lots of companies in this, yet even they can't indigenize the entire supply chain. So similarly, India, given its fiscal constraints, won't be able to do that either, right? So that's why just look at, for example, the R&D spending of TSMC alone. It is $28 billion this year, the capital investment in whatever they are doing. Whereas India is also trying to attract semiconductor manufacturing here, and the total outlay for the production linked incentives that we have is $1 billion, right? So it's just an order of magnitude difference. So what I have been writing about and arguing for is, we shouldn't be thinking of indigenization in the changed technological landscape at all. We should be thinking of ecosystems and not indigenization. And what I mean by that is, we don't need to have this entire supply chain in the country. I mean, it would be hugely costly, and the opportunity cost of those will be massive. And even if we are ready to put in that money, it's not necessary that these companies will come to India, because in the current situation, US, EU, China, all are doing the same thing, throwing money at the problem. So they would rather go to a country which is offering more money, has sort of better enforcement mechanisms, has easier availability of reliable electricity, water, power, rather than come to India, right? So the idea is, why would you want to do that when these two challenges are there? So I think of it as, India should rather have two strategic goals. One, broadly, we should have built enough redundancy in this supply chain such that no part of the supply chain is heavily dominated by China, which is our major strategic adversary. And the second goal should be that we need to build enough expertise in all parts of the supply chain so that collectively China could be outpaced. So, and I think to achieve both these two goals, we actually don't need full indigenization. We need to work on our comparative advantage, which is semiconductor design. And if we can sort of work on that, it will be good. And whereas a lot of manufacturing, as long as it is in places which are not under China's threat. So it's okay if it is in US, it's okay if it is in Japan. As long as we are able to access them, we don't need to worry about having them within India, So that is the way I think. I'm not saying that we don't need to have semiconductor manufacturing facility in India. We can have, but we don't need to have the leading edge ones, which cost $12 billion and require upfront investment, repeated subsidies by government. But we can think of the trailing edge manufacturing facilities, which are lower in cost and which still will see demand going up ahead. So they are easier. They are easier to build. We can build expertise in them, and then think of doing the kinds of things that US and EU are trying to do.
So, Pranay, I've also been reading your work. You, in this regard, you also make a case for a Quad partnership for India, right? So, I mean, continuing with this, how is it suitable for India? You already mentioned about the comparative advantage, and how can they actually, start this partnership? And it's one thing to have that idea, and another to, to convert that idea into a tangible outcome. So, how would you suggest they can do that?
Right. Yeah. So essentially, I sort of had this argument, as I told you, that it's probably better to think of ecosystems and not indigenization. And then when we think of ecosystems, where do we start was the question. And the idea is that already there is a geopolitical sort of alignment in a sense, which is taking place, that things need to be done to confront the China challenge. And the Quad is sort of already moving towards that. So given that there is already an alignment of sorts to move forward, I thought Quad would be a good place for such a kind of thing to happen. And Quad has already taken some steps in it. There is a working group on critical and emerging technologies, which currently has a really broad agenda. But my point was, why don't we start with semiconductors within that broad agenda? And how would it sort of work out? The way I have said is, there are really specific parts of the supply chain where these four countries have comparative advantages in as well. So US, for example, is a design behemoth. 6 out of the top 10 fabless companies are there. Over 62% of global fabless revenues come from US companies. They are really dominating in that part of the supply chain. Japan is a powerhouse in the manufacturing equipment material. So the really pure materials that you require for this, and the processes that you require, etching gas, silicon wafers, all are dominated by a few, 2 or 3 Japanese companies. So they have an advantage there. Australia is a basic materials provider, not so much in semiconductors, but they have silica deposits. Then they have a good mining industry, which can be used for composite semiconductors. And finally, India is the human power, right? As we discussed, there is a lot of semiconductor design development which happens in 30-kilometer radius from where I am sitting in Bangalore specifically. So there are these advantages of that. So you can see there are comparative advantages. Each country can plug in the gap that other country has in this supply chain. And that's why, and the weaknesses of each countries can also be compensated by the other. So that's why I thought Quad is a good point for us to start. And the way I think of it is, like Land Pritchett talks about isomorphic mimicry. And the idea is that why would we want to do what US is doing? We need to look at what are our own problems and what are our own advantages. So given that we have advantages in design, why don't we focus on that? And the way I would see this happening is India focusing more on the design front and on the trailing edge nodes for manufacturing, that is the older manufacturing facilities which are cheaper, and US, EU, Japan probably focusing on the more advanced one. And as long as we have arrangements, and I'm sure we can talk about what governments can do about this, but as long as we can have arrangements so that companies in each other's countries can benefit from this, we don't need to necessarily indigenize this. So I had proposed that we begin with something called a Quad Supply Chain Resilience Fund, which essentially does 3 things, which thinks of diversifying the manufacturing base. So like I said, do some manufacturing in US, some in Japan, some in India. Then collectively work on new standards development. A lot of geopolitics of technology is happening in developing standards, like how China got an advantage because their companies played a leading role in setting the 5G standard. So similarly, there are lots of manufacturing standards in semiconductors. So if these countries can come together and work collectively on new standards development, they will have a upper hand in this. And finally, if these countries can facilitate strategic alliances between the companies of semiconductor companies in each other's countries, again, it would be a good start. You don't require indigenization. You can build an ecosystem together.
So I think we're nearing the end of the time. So my last question, which is what you were mentioning. Could you tell us a little more about how governments can support the industry, and if you have some policy recommendations.
Yeah, so these are points that I'm still developing. So I'm sure economists here would have more insights into it. But one thing that I sort of, the biggest conceptual shift I think we require in our mind is the need to embrace an allied approach in technology, right? Like, I mean, we are still thinking of technology from the old industrial policy realm, that throw enough money at the problem, just like we had a steel industry which came up in India. If we throw enough money at the problem, we'll also have an entire semiconductor industry in India, which I don't think is the case. At least the evidence doesn't say that. Even US is finding difficult to do. So the way I would think of it is that it is important for governments to do what companies can't, right? Instead of trying to do this idea of throwing taxpayer money at the problem. And anyways, companies are better judges of efficiencies and comparative advantages than country governments are. So I would say specifically governments could do some things. So international relations wise, as I said, a lot of development here has happened through R&D cooperation across countries. So you have really lots of licensing agreements, cross-licensing agreements, technology exchange, visitation and research development, joint development, which happens across geographies. And if you think of it, governments have a role to play in each of them, right? So for example, if we remove technology transfer restrictions in the Quad countries, we could accelerate licensing and cross-licensing agreements. Similarly, easier capital flows could also foster more joint development projects. Currently, investment screening norms in this industry are very high. So if you could think of Quad countries or Quad plus countries thinking of lowering those investment entry barriers, then you could have a possibility of more joint development taking place, right? So these are certain things which only governments can do, companies definitely can't. That's one. The other thing, a lot of work in this sector happens through intellectual property generation. So you have a lot of work on patent regulation to do. So if we could have, harmonizing things, think of things like the patent prosecution highways which exist. So if there is a collaboration on that front, we could again encourage more joint development across these countries, right? So that's sort of from international relations point of view. Even domestically, I think India can think of the lots of problems why semiconductor manufacturing doesn't happen in India is not because specifically because of the semiconductor industry as such, but the problems are wider, right? Contract enforcement, revisiting our export controls, strengthening intellectual property protection. I think these are the barriers which stop a lot of companies from trying to invest in India. Because remember, as I said, there is a huge upfront capital cost that you need to put in, and you're going to get results only 5-10 years down the line. So if you are not confident of the contract enforcement, of IP protection, then no country is going to take that bet. Unlike in a software space where you could potentially move to another country quickly, here it would be very difficult to do. Similarly, I mean, the disability in terms of attracting other companies is broader, right? It is about taxes on fuel, electricity not being subsumed under GST and things like that, right? So in order to be more competitive, we have to go beyond just throwing subsidies at this particular problem. And the final thing I would sort of, one thing that idea that I'm pushing for is, if we want to have manufacturing in India, we should think of the trailing edge nodes, the older manufacturing facilities. It would be easier for India to develop expertise on that. And the fact that these nodes will still be important. Not everything that is manufactured requires 5 nanometer technology, requires huge capital investment. Even for things like 5G, you need baseband, which can be done on the trailing edge nodes. For most of the defense applications, most of the space applications, you can work on a trailing edge node, right? So it's better that we invest in those. Those I think are more strategic rather than thinking of indigenizing the whole industry. So that's how sort of I think of it at this point.
Great. So I think we have reached the end of our time. This was very insightful, and I really learned a lot today. So thank you, Pranay. I think I'll let the audience ask you questions now, and we can learn more about this. So I'll hand over to Sudhir, and Sudhir, maybe you can take the questions.
Yeah, thank you so much, Momita, and thank you so much, Pranay. We have a host of questions. So I would like to initially invite some people on the camera. They will come and ask their questions. So can we have Soumya? Soumya has a question. In fact, she has several comments and questions. So Soumya, can you please come on camera and ask a question?
Yeah, sorry, I'm not able to get the camera switched on, but if you can
problem.
hear me, I can ask the
Yes,
question.
yes, we can hear you very well. Yeah.
Yeah. So Pranay, very interesting talk, and I know you have a background from this industry. So whatever you mentioned was, really insightful in this 1 hour. The question I had was that, all these challenges you talked about in the foundry, in the supply chain, and the downstream processes are capital intensive. And let's say Taiwan and Korea and Japan have built up systems around that. So if you are in a quad collaboration, those pieces are taken care of. However, where India is very weak is always in upfront research. So when you had the supply chain, diagram where you talked of, the design part as a second stage, where, there's a lot of these service companies like Cadence, Synopsys, all the players who have big presence in India, doing all that. What we are essentially doing is global services, right? So the design belongs somewhere else. So how capital intensive, when you said 28 billion versus 1 billion, product PLI and all that, the point is TSMC is, the world leader. So what they are investing in research may be very different to what, let's say, a country could start doing for, let's say, auto chips for, let's say, Tatas or, whatever challenges they are facing. So what would be the research capex for doing something like that, which could place India at an advantage to be able to at least control the first 2 legs of the IC supply chain?
Hi, thanks so much for your insightful comment. So if you think of this industry again, the design front, already there are, it's not just services, so Cadence and Synopsys, the 2 companies you mentioned, are actually EDA companies. So they manufacture that software which is used for placing this humongous amount of transistors on a chip. So they do a lot of R&D work on that. Now, what has happened is, because there have been so many companies which are not Indian, but which have wide experience of doing the entire design cycle in India, working over the last 30 years, there is, I think, a critical mass of people who are experienced in doing even the R&D design work. And you are already seeing beginnings of this. There are a few Indian companies which have their own intellectual property in this space, and it is beginning to pick up. I think what is stopping a lot of this is, I think this industry would require a lot of patient capital to come in, not just from the government, but also from the private players. So, but we are seeing the beginnings of this. So an example I can give you is, for example, the government of Karnataka has the Semiconductor Fabless Accelerator Lab now. And essentially what they are doing is, they are developing, incubating a few semiconductor fabless companies. They are giving EDA licenses. Like I told you, this software costs really huge amount, and it becomes really costly for a startup to have these EDA licenses. So what this SFAL is doing is trying to give this, integrate the demand and give it to a few companies which they are incubating. So this is a government-led effort, for example, which is beginning. But I guess now, with the realization that this industry requires some resilience, patient capital by the industry would help us to sort of improve our capabilities on the design front as well. Now, so I think design is still, I see more possibly in the next 10 years, you will see India incubated companies doing great intellectual property generation design work. But on the research front, which was the pre-production stage, that would require a lot of, again, you need to, the pre-production stage actually operates on optimizing the silicon itself. So that requires much higher much higher capital investment. So that would require you to have fabs, that would require you to have close interactions with fabs. So there I see still a lot of difficulty. But on the design front, I think India is poised towards having many more companies which can do in-house design and intellectual property generation. And we are already seeing a few companies incubated in India, registered in India, taking those first steps.
Hi, Soumya is, hello. I think you have answered the question. Thank you so much, Pranay, and thank you, Soumya. Now I would like to invite Professor Amol Agrawal. He has several questions and a very interesting one. The last question is really interesting. So Professor Amol, can you please come on camera and ask a question?
Hi, Pranay and Momita, thanks a lot for this. It was quite absorbing. I hope I'm.
Yes, we can hear you.
Yeah. So Pranay, I'm obviously aware of your background. You were an engineer and all that, but still, it was quite interesting the way you narrated this semiconductor. And I believe you were earlier working in the semiconductor industry as well. Is that right? And is that what drove you to this sort of research on semiconductor industry?
Yes, so I used to work for around 6-7 years for 2 US companies based out of Bangalore itself. So, and I have seen R&D work happening in India. But yeah, back then our common complaint was, in technology, no one talks about semiconductors, right? Like
Right.
everyone talks about software. But here we are in 2020, the geopolitics has moved towards talking about semiconductors.
Yeah, so I mean, since you also looked at a lot of history in this, so I was just kind of curious, at what point of time did all these industries you're mentioning become so semiconductor involved? I mean, and I had no idea, and thank God I heard this talk today. It was quite interesting and also worrisome that so many industries have become kind of dependent on the semiconductor. And some questions have also come that the car companies and etc., which we all thought that run on petrol and diesel, but are basically running on semiconductors, and there is a shortage there. So what I had is, I mean, some thoughts on how did this reliance sort of on semiconductors start with the various industries? Any timeline you have? And are we thinking about some alternate to semiconductors? I mean, is there some technology at work where we are, since the shortage is happening, it is resource heavy, it requires a lot of financial capacity. So is there some alternative? And since you are also a foreign policy kind of a person, so what kind of discussions are happening on the global front? Is it a UN issue? Is it an issue where people are talking about it, that what is happening at the semiconductor industry, and to sort of look at lowering the risks of semiconductor? And my final question, sorry for many such questions. My final question is, if you could, point us to some readings on this. I think it's a very intriguing industry, and some kind of primers and some interesting things. And the way you narrated the story, maybe you have a thriller writing. You could write a thriller for us, explaining the geopolitics and the semiconductor industry. As we've read so many of those thriller novels around petroleum and oil, and we believe that semiconductor is the new sort of thing. And maybe Pranay can write a book, educating us through this. Okay, so thank you.
Yeah, thanks so much. Amol, so I'll just go through the 4 questions. So there have been different dates where, different eras where you had this idea of semiconductors being used in different industries. But the whole process has been that you replaced mechanical parts with electrical parts at different points of time, and then electrical parts got replaced by electronic parts, right? So when that stage happened in each industry, you had at that point of time you started needing semiconductors. So for example, one of the first companies which did this was Texas Instruments, and Texas Instruments originally used to work on geophysical oil exploration kind of work back in Texas, and then they wanted to have better technology to detect this, and that's where sort of you started moving towards electrical and electronics and then semiconductors. Also think of it, for example, in automotives now. As you are moving away, we are seeing a transition in place, right? As we are moving towards EVs, the value of semiconductors in your entire chassis will keep increasing. So it's similar things have happened across different industries at different points of time, right? So that's essentially why you would need more and more semiconductors. Second, you asked a very interesting question on alternatives. So yes, a lot of work is happening on that because the upfront costs, as I told you, are very high. So, and the more important point is you're actually hitting the limits of physics now. You're literally a few atoms apart. Each of your transistors are a few atoms apart, and that leads to a whole lot of complications. So people are thinking, can you use things other than silicon? So there are a lot of advancement research happening on using, say, composite semiconductors, which have slightly different properties. Also gallium nitride, which is used, and that the cost of manufacturing those are arguably lesser than that of silicon. So, but a lot of this is happening on the research stage. So DARPA, for example, has funded a new program called the Electronics Resurgence Initiative in 2019. And a lot of it is focused on this. Can we get alternatives to silicon? Can we improve the security so that there's no espionage? So a lot of that work is beginning as we speak, and I'm sure in the next 5-10 years we'll see some alternatives coming up. On the foreign policy angle, I don't see any sort of UN related efforts happening on this, but it's mostly the same industrial policy mindset. So a lot of countries are having government programs for semiconductors now. So it began with China's Make in China 2025 initiative in 2014. Basically, they offered a lot of incentives, and you had companies, food companies, which are now trying to manufacture semiconductors there. They have invested, the government, once you put money, you can crowd in a lot of investments, right? So a lot of them have failed, but you won't, anyways, it's people, so there is food companies coming into it. There are also local governments in China which have invested in semiconductor companies. So that crowding in is happening, but the results are not commensurate at all. So a lot of investments which are happening currently, I see, are of that kind. Each country trying to see what part of the supply chain can I indigenize. So US, EU, Japan, India, including, all of them are doing that. But collaboration at this level is not happened yet. I know in Europe, EU has funded a program to do this thing at the EU level, but not EU, US, etc. Those are just beginning. So for example, EU is now trying to attract Intel to do a few things there, so on and so forth. So it's bilateral initiatives have begun. Multilateral initiatives, probably in Quad, like I said, in the working group, semiconductors is one of the things for discussion, but no concrete steps at a broader multilateral level, and definitely not at like a UN scale. Finally, on readings, there are very few books on this subject because the technical folks concentrate on the technical part, and the geopolitics is just something which people are now focusing. But I would say there's a book called Fabulous by Daniel Nenny, and it talks a lot about what I mentioned. And there is also a book called Tiger Technology. I think that talks a lot about how the East Asia miracle in semiconductors took place. So these are two books I would recommend. There are a few good papers on this as well. Probably I can share a link but yeah, the space is limited, and yeah, I would love to write a book on this at some point. Thanks.
Thank you, Amol, and thank you, Pranay, for answering that. Now I would like to invite Praveen Tripathi. He has a question. So Praveen, can you please come on camera?
Yes, sir. Thank you for giving me this opportunity. Very, very informative and educative talk. My question is success in semiconductor industry driven more by access to critical raw materials, or is access to materials now reasonably democratized? But it is the manufacturing processes and design of chips which drive success of this industry. Which is a more important factor? I mean, all three matter, but which is the one that actually determines the success?
Yeah, I think it's tough for me to say which is more difficult, because there are bottlenecks in all these. Again, raw materials, for example, as I said, that the rate of purity which you require are only manufactured by 2 or 3 companies. I mean, 2 or 3 Japanese companies, plus there will be others in the world, but they occupy 60-70% of the that supply chain. So then there are bottlenecks in the manufacturing equipment. I think that is a big bottleneck. As I said, if you want to make an Apple iPhone processor chip today, and the manufacturing equipment which will actually carve out the chips on the wafer is just manufactured by one company in the world, right? So manufacturing equipment is a bottleneck. Manufacturing capacity itself is a bottleneck because of contract manufacturing being so costly and being dominated by a few countries. Also, please, one thing that I didn't mention earlier, these manufacturing industries are hugely environmentally polluting as well. So East Asia made that trade-off. Why industries moved away from the US, one of the reasons was also that the environmental costs were significant, and East Asia made that trade-off. Some countries that we will sort of try to mitigate those effects in other ways. So that is another bottleneck, that you still have these manufacturing capacity in a few companies in a very few countries. So that's another one of bottlenecks. So these bottlenecks, I don't think there is a big bottleneck in the design front. You still have, because fabulous companies exist widely across the world, that is not a bottleneck. But apart from that, EDA companies, like Soumya mentioned, there are just 3 companies, all of them US, which do EDA licensing. So if tomorrow US companies would to say that Chinese companies, you can't get any of our EDA licenses, and then Chinese companies will be really struggling. They don't have an EDA equivalent like the other 3. So there are these bottlenecks across the supply chain. So it's difficult for me to say which is more of a big bottleneck. But I would put raw materials as out of the 3 or 4 bottlenecks, definitely one of them, and it still exists.
Thank you, Praveen. And we have a lot of questions coming up now. So I would like to invite one of our students, MBA student Neeraj, who would like to ask a question. Neeraj, can you please come on camera?
Am I audible?
Yes, you are. Please.
So Pranesh, I heard that N. Chandrasekaran, the chairman of the Tata Group, says the Tata Group is about to enter the semiconductor manufacturing business, and they already have a high-tech business set up for it. And that would unlock a GDP growth opportunity worth $1 trillion, and also millions of job opportunities. So thoughts on that?
Yeah, no, I think that's a positive sign, like I mentioned, because now there's a realization that you need some resilience. It's good that there is some patient capital which is coming in this, and I would also like to see if there is some patient capital which comes in on the design side. Like we discussed, it's really a comparative advantage for India. So if some companies are backing product companies which are doing chip development, that might be really useful. Secondly, if they are able to, if Tata's is able to get a manufacturing setup up, and again, we don't need to manufacture iPhone chips. If we are able to manufacture chips which go into 5G baseband, if we manufacture chips which go into automobiles, which are not the leading edge ones, definitely, then it would be a great start, so there are beginnings of this. Let's see how it works out. I'm not very optimistic because such promises have been made in the past and many times before. Intel promised one thing way back in 2003-4. There were a lot of talks, but because of cost and competitive advantages, contract enforcement concerns, etc., it didn't pan out. Then there was a second big attempt at this where a consortium was formed, and they wanted to start a fab way back in again in 2010 around in Hyderabad. That also didn't take off. So this is, in my experience, the third time we are seeing a big industry-led effort which is concentrating on it. So the idea is, are we doing something different? I'm not so sure. So so let's see how it works.
Thank you, Neeraj. Related to that, there is another question by Professor Pallavi Vyas. So I would request Professor Vyas to come on camera and ask the question.
Hi, Sudhir. I'm not able to. Now I am. Yeah. This is really an eye-opening conversation, because I had no idea that this was like almost like as important as steel. This is like our livelihoods are dependent on semiconductors. So I just had a question on leveraging the human capital that's involved in this industry. Like, I'm sure like a lot of the industry has Indians working in it in the US and in other places, right? Can we leverage that somehow and create some type of model of communication with India to develop anything? I don't imagine that they would move back, or, it wouldn't be easy unless, like I just moved back from the US for personal reasons. And I understand, like, it's not easy. Like this transition is not easy, and the pay scales will be just at another level over there. But just the knowledge and the know-how, and because I know in economics, they're doing that, right? Like, Abhijit Banerjee, all of them have got funding for Indian projects. You know what I mean? Like, so is there something that is being worked on or can be done?
Yeah, so I think joint development is something that definitely has a potential. So, and I think governments have a role in it. Like I said, technology transfer regulations in this sector are high because every country is seeing it as strategic, right? So that's why my argument is, if we think of it as building a quad or quad plus or any other, I'm not hung up on quad, but just that this is a starting point. So if we can lower some of those barriers, I think a lot more cross-licensing, joint development can happen. And as you correctly mentioned, there is a lot of Indian community expertise in this industry in the US, in Europe, etc. So definitely a potential to leverage. And you can see some of that happening in China. Like a lot of people who have started companies in China in the semiconductor space are people who have come back from the US. So I think returning back, as you would know better than me, is also a combination of the fact that overall living standards, overall opportunities, how do they evolve? So in China, that has happened. And I think once that happens in India, you would also see some people relocating here. But definitely on joint development, I see potential if we can lower some of these barriers.
Yeah, just, even if people, I understand that people may not want to relocate, but I think every migrant wants to give back. like it's just in, not every, but I would say 90%, right? So there's so much potential. So what particular sector would you think that would be possible? Like what was, I mean, since semiconductor is pretty wide, like what particular area do you think that would be possible in?
Yeah, so I wouldn't know, for example, what could be an economic instrument for it. Like, can we have a sort of a bond which sort of helps us make this, create an industry back in India? But I think one sector which is really easy for joint development to happen is just the design part. So that's where you can, there is a lot of expertise in India because of 30 years of this industry. So that can be leveraged definitely. So if there is some investment backing some of the smaller startups which are coming up in this space, by people in the US, I think that is something which is quickly doable and possible for us.
Thanks.
Thank you, Pallavi. Now, as it was said that you are surrounded by Pranay, you are surrounded by economists. So now we have one MA economics student, Ayush, who would like to ask a question. Ayush, can you please come on camera and ask your question?
Yes, sure. Hi, sir. My question is actually that given the geopolitical situation, as we can see now, we are very much interdependent on each other. And that's a great thing. But there is a sort of kerfuffle going on that like in 2008, the crisis came, Lehman crisis, and there was a ripple. So can we be sure that we should not be, or we should not be kind of very much self-sufficient in semiconductor industry, given that everything revolving technology is now with semiconductor. So can we be really sure that we should not be going in that indigenous project way and relying on interdependent market structure? I mean, if there is some shock in future, we can be affected. So how should we devise our policy in this regard?
Yeah, Ayush, cool guitar, by the way. So yeah, so I would say yes, we have to think of what is strategically most important to us and probably think of narrowly sort of focusing on that. Now, the way I think of it is, if you think entire semiconductor supply chain is strategic, there is no way how much ever money we put and with the opportunity cost also that we will be able to indigenize it. I mean, there is good practical reasons why even the US couldn't do it, right? There was all these manufacturing facilities moved to East Asia for very good economic reasons, so for us to be able to overturn those economic advantages just would require humongous amount of resources with no guaranteed success at all. Second, I would say, but as you said, that there are certain things that we would want to be assured of. So what I would think of is in trailing edge nodes manufacturing, for example, if we are able to secure chips for some of the most critical things that we do, say space, defense, etc., that would reduce one sort of dependency. But remember, even like defense sector, for example, chips would be just one part of a fifth generation multi MMRCA that you're going to have. You need many other components to fall in place, for which you might not have the entire expertise in India, right? So you can probably cover one part of it, but not the entire thing. So the way I think is, I mean, you think of AI chip development, or if you think of any of the recent technology industries, they are very globally diversified. For example, a lot of AI research, recent data suggests 30% of the top papers, more than 30%, I think, are generated by migrants who are in one country or the other. So there is really the new technology industries are in the form of global supply chains. So to think of indigenizing that as a whole is sort of To me, it seems nearly impossible. So better to have a narrower definition of what is strategic and then focus narrowly on that and play on our comparative advantage, which for India in this sector is definitely designed. So why not take that advantage? Get most of the countries in the world to manufacture any chip out of India, right? So if we are able to achieve that goal, I think we would have done well. Remember, in this entire supply chain that I told you, the value, the maximum value that is captured is in the design cycle, not in manufacturing, because manufacturing, again, you have to do a humongous amount of manufacturing. You have to ensure a plant load factor of 90% or above in order to make profits. So only few companies in few countries would be able to do that. But we already have a big talent base in design. So why not take advantage of that, capture that part of the supply chain across the world? We can make a lot more economic sense through that means. And we can have interdependence, right? Others will be dependent on Indian expertise as well. So that's how I would see.
Thank you, sir.
Thank you, Ayush. As I said that we would be taking 5-10 minutes of an extra. So I have last set of couple of questions by Ramanik Shah. The first question is, can India take lead in functional testing, encapsulation, and the assembly of products in semiconductor? And the second one is, a massive supply of a specific grade and quality of water is needed in fabrication of ICs. Any advantage of India having it from our vast Himalaya range? Please, these are the two questions. So,
Right, thank you. So just talking about the testing and the outsourced assembly and testing part, right? So currently, as from my industry survey, I think there are around 2 or 3 companies in India which do this. But like I said, one, it is labor intensive. Second is there are low cost margins in this. So what you would again want is it's a chicken and egg problem here. Most of the companies, like in Taiwan, has a really big outsourced assembly and test business as well. The reason being that they are also manufacturing chips. So TSMC manufactures the chips, and it is easier for them to then hand it off to another company which is located closely for doing assembly and test, right? Because you need to be able to hit the cost margins and achieve. So, but if you have assembly and test in India, without you having a foundry here, the cost of transferring the chips and then the possibility of in the transportation, you would have some misfunctionalities arising are high. That will again lead to lower yields, lower profit margins, right? So I think that's why a lot of people in the industry talk about whether you need to have a good foundry before having an assembly, or whether you can have assembly which can profitably make money even if the chips are manufactured in other places. So that's where the debate is now. The government has introduced a lot of subsidies for the assembly and test sector as well. So we'll see whether that sort of has any advantages. But what I already we are seeing some higher level integration of mobile phones, etc., happening in India. So that's one positive side of the other end of the supply chain, which might generate demand. So Samsung has a really big integration thing for their mobile phones in India. Similarly, you all know about Wistron and other suppliers, Foxconn, trying to have operations out of India for Apple phones. So that is beginning. I think that might generate some demand for doing the next level of the supply chain in India, which is assembly and test. But yeah, I mean, given that it is labor intensive, we have some comparative advantage again in that. But a cost disadvantage is just that we don't have foundries, so you will have transport costs, which will be significant. That was one question. Sorry, what was the second one? I sort of forgot.
Second one was about, I'll just quickly read. Massive supply of a specific grade and quality of water is needed.
Right. Yeah. Right.
And there is another question by Pranshu, which is around the environment. That how does this affect the environment? Okay.
Yeah. So again, for water, yes, it is a concern, but I would think that we need 1 or 2 facilities for this. We don't need 30 areas which have this facility. So with 1 or 2 facilities, maybe I know that the types of areas people have been talking about are either Hyderabad, or there have been talks about this in Gujarat as well. So those are the areas where people have been talking about, not in close to the Himalayas. At least I have not come across any debates on that, but mainly also because you need an ecosystem of people who are working on this already, right? So for example, Bangalore, Hyderabad already have a base of people who are working on these areas, so it would probably be advantageous to locate in that area. So yeah, I mean, water is a requirement, but I guess in any part of India, if we need one strategically important industry, India should be able to get over this water requirement, right? I mean, we can do that. So that's where I have heard. Nothing on the Himalayas or close to that I have come across, at least.
Okay, thank you. Pranay, I have a last question, and I wanted to ask, in February, I read somewhere that when Joe Biden came, he held a chip and he showed it, and then he signed. Generally, I have never seen that kind of display when you're going to do something and you want to communicate something differently, but he did it. And after that, we have been reading about chip wars, and then people are equating. Though energy war was entirely different, it was partly religious, partly strategic, and otherwise as well. But what kind of war is this chip war? I mean, we want to know if you can throw some light on that. And why would somebody do that kind of display? Do you think the timing after COVID, because technology is going to be, I mean, taking over everything? So what are your thoughts on these two?
Yeah, I mean, great question. Yeah, he displayed the chip, and before that, the Congress also had an act for this, which was called CHIPS. So, I mean, some big acronym, which essentially means that you need to attract semiconductor companies back to the US. So, a lot of there are a few dimensions of this chip war. One, as I said, is US. China is probably if you think of the technology stack of China, one weak link that it has is semiconductors, right? Because it does not have manufacturing facilities of the kind which are there in Taiwan or which are even there in the US. So on the design section, they have a few companies now. On manufacturing, they have trailing edge nodes, a few foundries, but not like TSMC, and on the manufacturing equipment, etc., they don't have an expertise. So if you think of strategy being this idea that you need to attack an adversary's weak link rather than play on their strong points, that's what is happening now. So US realizes that China's weak link is this, and because it's a metacritical technology, they would want to develop this faster. That's why China is giving big subsidies since 2014 for this, and that's why what US has used this weak link of China to sort of deny companies like Huawei access to the leading edge semiconductor companies, and that's why the secondary sanctions which have come up, right? So that is one dimension. Again, so Taiwan becomes the center point of this. That's one. The other thing that I said is, because this one company is so important, there are a lot of cyber attacks which happen. There are threats that, what happens if this company is taken over, or if this company's production lines are brought down, and what are the ripples that it leads to geoeconomically across the world, right? So that is the second angle. The third angle, of course, is what I spoke about of the espionage side. So hardware espionage. And there are allegations, though not confirmed, about how there are certain chips which were put on motherboard to spy on what is being used in data centers, right? So again, an access to what other countries' intent is can semiconductors be used as a tool for getting that information? So these are a few dimensions through which chip wars are happening. Yeah, I mean, you're seeing the geoeconomic implications also of this. Another interesting angle, for example, I told you ASML, that one company which manufactures the equipment. Now US has also pressured Netherlands to not allow the supply of that to Chinese companies. So Chinese foundries, fabs which wanted to do leading edge development, they are dependent on this one company, and US has been able to deny Netherlands from supplying that. How long that ban remains, we don't know, but they have not been able to do that, supply that leading edge equipment. They are supplying the older equipment there. So, all these countries are getting embroiled in this whether they want or not. So that's how I would see it playing.
Thank you so much, Pranay, and thank you so much, everyone. And Pranay, you are very generous that we took your more 10 minutes, 15 minutes, and you agreed to it. And one thing that I really liked about this conversation is it is a very complex topic. And for most of us, it was an educative experience. We learned about it, we came and we participated, and we made everything so simple. So thank you so much for that conversation. Thank you so much, Momita, for asking those questions. And I mean, that's all. Thank you so much for joining us. And we look forward to have you on the campus on this topic. I think more and more discussions should happen on this in terms of curriculum, otherwise in the classroom. This is going to be one of the most significant things which is already there, and it is going to shape us in a very different way, particularly in India. So thank you so much, everyone, for joining, and take care. And thank you, Pranay.
Thank you, Momita, Sudhir, Swati, and everyone at Ahmedabad University. I hope there was something new that I brought to the table with this. Bye.